Hello again! In today's lesson I'm going to talk about functions or methods as they are called in C#. Ever wondered, as a beginner, inexperienced programmer, how are engineers able to create huge programs such as mobile apps, websites or operating systems? How are they able to keep track of the countless and countless lines of code that such projects require and what each of them do? Well, nowadays programs have become so complex that no one could ever write a complex program from start to end in a single block. To overcome the complexity, programmers have split such programs into functional subcomponents called functions or methods, using the old Roman concept of divide et impera, meaning divide and conquer. According to it, a complex task should be further divided into smaller sub-problems, which can be more easily solved individually. Specifically for programming, a method is a basic, simple part of the program, designed to perform a single specific task. Or, in other words, methods are the functional part of the programs. This is where the real job gets done. In the previous lessons, even without knowing it, you have already seen a method called main, which is the first method to be executed when the program starts. This is how a typical method looks like. And this is how a function looks. Most of C# programmers use the terms method and function interchangeable. However, I prefer to make a distinction between them just to make things a little bit more clear. In my opinion, a method is a piece of code that does something autonomous, for instance, printing a file. Such a method contains the codes for printing a file, and we can execute it without waiting for anything in return. On the other hand, I see functions as a piece of code that we execute because we expect them to give us back a result. For instance, if we execute a code for calculating square roots, we expect a result from that code, which represents the result of its calculations of square roots. So, you may not need to respect this convention, but it might help you state more clearly what you mean. Both methods and functions need a block of code, which delimits where the code that they contain starts and ends. For methods, we use the keyword void, which indicates to the compiler that our block of code is not expected to return a value when it finishes its execution. On the other hand, when using a function, we need to declare the type of the value that the block of code returns when it finishes executing. In our case, we return an integer value. This is also the reason why we must use the return keyword. A method or a function needs a three-step process in order to be of any use to us. First, we need to declare it, just like we normally do with a variable. The difference is that we declare our methods inside classes blocks, just like the main method is already declared. When you declare a method or a function, you must specify its type, name, and eventual parameters so that the compiler can identify it. On the second step, we implement it. As I already said, they require blocks of code, inside which we can place the codes that the method or the function contains. Finally, in the third step, we call it, which means invoking the already declared and implemented method or function from some other part of the program, where a problem that the method should solve must be solved. Sometimes we need to offer certain relevant data for the methods and functions to solve. This can be done through parameters. One of the primary goals of methods and functions is called reusability, and this means that we don't need to copy and paste the same code over and over again every time we need a certain action to be performed. For instance, consider this example. You already know that the area of a rectangle is its width multiplied by its height, so we are calculating the areas of 3 rectangles, but it becomes pretty obvious that the code is kind of repetitive. What would really help us would be a single piece of code that would give us the area of any rectangle we want, and this can be achieved with a method. And because we want our method to process the area of any rectangle, we also need a way to tell it the values of its width and heights of our various rectangles, and that can be done through parameters like this. The first step is to declare the method. Do not bother with the keyword static for now, it will be explained in a future lesson. Since it is a method, we use the keyword void as its return type, which means it returns no actual value. Then we give it a name so that the compiler can identify it among any potential other methods. Finally, inside the parentheses, we can see these two float declarations that look almost like variables declaration, except we don't assign values to them. These are actually the parameters of the method, and their value must be given when this method is called, which is the next step we need to take. I already said that a method is useless unless we call it whenever we need it to execute its codes, and that we do that by specifying its name, followed by parentheses. In this case, you can see that we get 3 errors because the method we are calling has 2 parameters of type float, and it expects us to give those values when we actually call it, like this. When I run this code, you can already see that the output is identical to the one we had before. You can also see that the code is much shorter and less repetitive. So, to sum it up, the way we send values inside our methods and functions is through parameters, and a parameter is declared just like a normal variable when we specify its type and its name. We can have as many parameters as we want, and they are separated with comma. The type of the parameters can be primitive types like int, float, or references like arrays, lists, classes, and so on. Without knowing this, you've done it countless times before. Whenever we use console writeLine, we actually call the method name writeLine, which is declared inside a console class, to which we send a parameter of type string. This becomes more visible if we look at the signature of the method or its declaration. We can see that it expects a parameter of type string. This is also the place where you can notice the helpfulness of some Visual Studio context menu options. Big Definition opens a small window where we can see the declaration of methods and functions. It is useful for quickly seeing the declaration model of the methods and functions we use, without actually navigating to the folder and opening the file inside which they are declared. If we do want to navigate to that file, we can choose Go to Definition. We will later learn that we can also use Go to Implementation when it comes to methods or functions declared inside interfaces. Lastly, if we want to find all the places in all the files where a function is called, we can use Find All References. This becomes very useful in large projects with hundreds of files. Returning to the method's parameters, we also need to talk about the concept of variable scope, which means, in simple terms, the area of code inside which a variable is visible and can be accessed and used. To better understand this new concept, take a look at this example. Variables can be categorized by scope in 2 main types: variables declared directly inside the class, which are also called fields or members, and variables declared inside methods or functions, also called local variables. So in my code, we have a class named program that contains a method called main and a function called auth, plus two additional variables, a field variable called myFieldVariable and a local one called myLocalVariable. Although my local variable was declared inside the code block of the add function, I am trying to use it inside the code block of the main method. This is the reason why I'm receiving a compiler error when I try to run my program. The name myLocalVariable does not exist in the current context. On the other hand, you can clearly see that my field variable is perfectly accessible and does not generate an error. If I move the declaration of my local variable from the body of add to the body of main, you will see the compiler error going away. This means that a variable declared inside a code block is visible inside that code block. When we declare a variable in the code block of main, we can use it inside the code block of main. There is one exception from this rule. We must declare the variable before we try to use it, even if both actions happen in the same block of code. This is only logical. We cannot use something before we actually declare it. From the fact that my field variable is visible inside the main method, we can deduct the fact that variables are also visible inside a block of codes that are nested inside other blocks of code. Since the block of code of the main method is declared inside the block of code of the program class, and the myField variable is also declared inside the block of code of the class, that means it is visible inside the entire block of code of the class, and any additional blocks of code that are declared inside it, be it methods, functions, loops, conditional statements, and so on. So the general rule of variable scope is that they are visible in the same block of code where they are declared, plus any additional child blocks of code declared inside the block of code where it is declared too, no matter how deeply nested they are, but they are not visible outside the block of code where they are declared. This is also the reason why my local variable was not visible inside the main method when we declared it inside the add function, because it was not visible outside the block of code of the add function. Look at the following example. Because the day local variable is declared inside the display message method, it means it is visible inside this code block and any additional child code blocks that it might contain, such as all the blocks of the if and else checks. This is why we can change its value in all of them. However, since our local variables are declared one inside each of the blocks of the if and else, and since a variable is not visible outside the code block inside which is declared, this means that this block of code has no idea about the contents of this other block of code. It is also the reason why we can have three different variables, all of them called our, and the compiler gives no error. They are all declared inside different blocks of code on the same scope level. We only receive an error when we try to declare two variables with the same name in the same block of code or inside child blocks of code, because, like I already said, variables declared in a block of code are also visible inside child blocks of code, which means it would confuse the compiler when trying to determine which of the variables we are referring to. One exception from this rule is having a field variable and a local variable with the same name. This is permitted by the compiler, which will use the closest scope variable. In this case, the local variable will override the field variable. Now, let's discuss the execution workflow when using methods and functions. Whenever we call one of them, they take control over the execution workflow until the code inside their body finishes execution, and only then they return the execution of the code where they were called. If the code also calls inside this body another method or function, the execution is yet again transferred to the new location where it continues until it finishes executing all the lines of code inside it, and only then returns to the previous location where yet again will continue execution until it finishes executing all the remaining line of code and so on. So always remember, no matter how many times we call a method or a function, the execution is always transferred to the new location, and only when it finishes executing all the statements inside it will return to the initial point. What happens if you want to call a method that has some parameters, but we would want some of them to be optional? Analyze this example. If we give a value to one of these parameters, not only does it really look like a variable declaration and initialization now, but it also becomes an optional parameter. Now we can call some method with 2 or 3 parameters and we receive no errors. This is because whenever we don't specify a value in the method call, the default value that was given in the declaration will be used. We can have as many optional parameters as we want, but they must be placed at the end of the parameters chain. So, once we declare a parameter as optional, we can no longer declare mandatory parameters after it. Let me clear the screen and write these 2 lines of code. You've seen them plenty of times before and you know what they do. They display something at the console. Anyway, don't you wonder how I managed to call the writeLine method with a string parameter and then an int? If I would declare a function called displayString, which takes a string as parameter, I would not be able to call it with an int value. This doesn't work. True, I could create another function called displayInt, which would take an int parameter, but we have already seen that the writeLine method has the same name for all its variants. How can that be possible? The answer is what programmers call functions and methods overloading. You know how we cannot have 2 variables with the same name inside the same scope? This is also true for methods and functions, but only when their parameters type and count is the same, which means I can declare a method called display that takes a string as parameter, and I can also declare another method called stdisplay if I make it take an integer as parameter. Since the types of the parameter of the 2 methods is different, the compiler can't differentiate between them, even if they have the same name. If I call the display method and I give it a string, it implies that I want to call the one that takes a string as parameter. Subsequently, if I call it with an int value, it will know I am referring to the one accepting an int parameter. We can notice this whenever we write the parentheses of the method call. It says one of 2 versions available. Cycling through them shows that one takes a string, one takes an int. This means that Visual Studio is smart enough to detect that we have multiple versions of the same function and groups them together as overloads. And now we can notice that the writeLine method has no less than 19 overloads, which is also the reason why we can practically call it with any kind of variable type. The concept that is used by the compiler to differentiate between different overloads is called a signature. Every method or function has a unique signature which is determined by its name and the number of type of its parameters. So, a method that is called doSomething and takes no parameters is different than a method also called doSomething that takes a string as parameter. This is because their signature is different, because their parameter count is different, or having yet another method called doSomething with still one parameter but of int type still results in a different signature because the parameter type differs. In other words, the compiler only needs to be able to differentiate between the various functions and methods of a class. Be aware that the return type of a method or function does not take part in the signature declaration. Even if we have a method called doSomething that takes no parameter and returns void, and then we declare a function also called doSomething also taking no parameters but returning an int for instance, the compiler will generate an error. This is because while their return type is different, void, as opposed to int, this is still not enough to determine which of them we intend to call when we try to use them. This is also the reason why the error given by the compiler is that the call is ambiguous between the methods. Speaking of functions and their return type, I already said that they not only perform some computations, but they also return a value to their caller, or the piece of code that called or invoked them. You can imagine this as if placing the return value in the place where the function was called from. Therefore, we can call a function to assign a value to a variable, in which case the return value must be the same type as the return type of the function, like this. We can use it in expressions, which means using the return value directly inside expressions in calculations, like this. Or we can use its return value as the value sent to the parameter of another function, like so. I already explained that we return a value from a function using the return keyword. The blueprint for a function looks something like this. And remember, when you return a value, you must return a value of the same type as the return type of the function, otherwise you will get a compiler error. It is pretty obvious that you cannot return a string if the function has a return type of double. However, there are a few cases when we are allowed to return different types due to implicit conversion when there is no danger of data loss. I have already explained what implicit conversion is in a previous lesson, but basically, if the function states that the return type is float and you return an int, the compiler is able to convert from int to float automatically behind the curtains, because int has no fractional part and its range is far smaller than that of a float. Therefore, any int can fit in a float and the compiler can convert it without danger of data loss. Always remember that whenever the compiler meets the return keyword, it will immediately exit the function and return the desired value. This implies that any other code that follows after the return statement will never be executed. The compiler is even smart enough to warn you about it. It is not mandatory to declare a variable in order to return a value inside a function. You can always directly return a value or even the result of a different calculation. You are even allowed to use the return keyword inside normal methods that return void. However, in this case, you can only use the return keyword on its own, without being followed by an actual value. And this does not change the fact that the method does not return a value, so you cannot assign the call to a variable. Instead, using return in this context will only have the effect of exiting the method's body immediately and returning the execution to the point where the method was called. In other words, you can use return inside methods to stop or cancel their execution. One last thing to remember about functions is that we must always ensure the fact that we are returning a value no matter what. Consider this example. This works perfectly fine. However, look at this example. The program no longer compiles and we get an error, not all code paths return a value. If you actually analyze the code, you can figure out the problem quite easily. If x is greater than y, we return 1. Otherwise, if they are equal, we return 0. But what happens if x is smaller than y? We have no piece of code that returns a value from our function in this particular instance, and because you already know that it is mandatory to return a value from a function, the compiler just tells us that there are situations when we are not doing so. So always make sure that you do return a value from your functions, no matter the case. And with this, we conclude this lesson. In the next one, you will learn about recursion or recursive functions, which are functions that call themselves. Until then, all the best to you.